Yeah. In this chapter, I would like to look out for a risk called model risk. It's one of the key risks as a part of the operational risk. So, generally, what we see in the financial world is we create a lot of financial models. And of course, whenever we are talking about financial model, it should be something that takes a set of financial related inputs. Then, based on certain calculations, it will generate the necessary output for me. So, that is what we create as a financial model. And at the same time, the moment I change the inputs or I want to check out for what if analysis, if this input changes by this much, some kind of sensitivity or scenario based analysis, if I want to change some of these things, how would it impact my output? That is what we try to understand with a financial model. And in general, the financial model is built with some set of assumptions and calculations. And what we say is the kind of losses or the kind of wrong decisions that come up because of the usage of the wrong financial model, inappropriate financial model is what we are attributing to the model risk. Any loss or any chance of a loss that is coming up because of inappropriate associated with the model, with the financial model that has been created or been used, we associate it to model risk. Now, just trying to understand some important things of it, wherever we are getting into a risk because of incorrect model, either because of the usage of an incorrect model or because of creation of a wrong model or whatever, if we are not able to replicate the real world, replicate the real output using our financial model which has been created with some set of assumptions, if the replication is an issue, that is where we are associating it to a model risk. By in general, there is a saying which goes like most of the models are having some level of defects or some kind of problems associated with them. No model is perfect. Probably I should make this statement. No model is perfect. So it's only the intensity and to what extent it reflects the real world scenario. The more and more complex scenario I'm building, some kind of structured product modeling or some kind of exotic options modeling, probably which requires a lot of assumptions about various input parameters, modeling them and getting the reflection of the real world output is going to be a big challenge. And if we look at the way how the model goodness is assessed, they are generally assessed based on its predictive capabilities. Any goodness of a model, right? It is based on if I give a set of inputs, what is the output that it is generating. So it is generally evaluated on this basis. So for now, if it has generated a good output, it's a good model. But generally, what is suggested is if it has been evaluated based on the assumptions and probably the conceptual aspect of the model, the conceptual aspect, the formulas and all that have been used, underlying assumptions that have been used in building of the model, probably it could be understood much more better. But in most common cases, we see that the evaluation or assessment of the goodness of the model is based on what is the output that it is generating. So probably it should be said that the model correctness is evaluated from an output perspective rather than the inputs which it has used to build the model. So what we generally see is if the inputs are more and more complex, it's very difficult to replicate the real world. So because there could be lots and lots of relations between the various inputs, more correlations could exist between the various inputs, and there is a possibility of more factors to be omitted or unobserved, which could very well result in more and more error. So when we are talking about measurement from an output perspective, it may very well happen that if the model is very simple, probably the error may be much lesser, but if the model is more complex, it may result in a higher error also. But one thing all of us need to accept is there is no model which is perfect, which means every model has some level of flaws or not. Some, if not many, at least the flaws are existing to some extent. So understanding the limitations of the model and then using the right model in the right context are what some of the things that can reduce the model risk for us. So before we are trying to reduce the model risk here, we have to understand what are the various sources because of which the model risk can come up. So the first of them is incorrect specification. When we are talking about incorrect specification, probably the initial definition itself is wrong. Right? The initial conceptualization of the model itself is wrong. I may assume a wrong distribution. Probably I should have taken for some particular data, I should have taken a fat-tailed distribution, but I have gone ahead with a normal distribution. So the underlying distribution itself is having an error, which means the output that it could produces could be an erroneous kind of an output itself. So the specification issues could be there right at the specifying the underlying distribution, or I might have omitted some important factors which could have influenced my output. Right, if there were 5 factors that are influencing the output, I might have considered only 3 or 4 of them, which will distort my output heavily, because if the factor is very important or very relevant, it may have a big impact on the output that come up. And relationship between the factors, correlations. I could have considered the factors, but all those factors are really not independent. There might be some kind of interrelationship that could be existing between the various factors. So did I consider for those interrelationships? And if I had considered them, what did I do? Probably in a regression scenario, there is a possibility of uh, multi-collinearity kind of scenario, because all these independent variables need not be really independent. So how did I address the problem of multi-collinearity? Did I do some kind of factor analysis in terms of dimension reduction, or a principal component analysis in terms of dimension reduction, and then used it for my risk calculation purpose? And in some cases, we also see that the model risk comes up because of some factors like transaction costs, taxes. They are not considered adequately into the model. So while we are defining the initial base model itself, there are some kind of flaws associated with the model. They go as a part of incorrect specification kind of aspect. Then there is a possibility of flaw that comes up, risk that can arise because of not the specification of the model, because of wrong usage of the model. The model application is incorrect. The usage of the model is incorrect. Means the model building wise, it's a proper model, right? It has been built properly itself, but it is being used for the wrong purpose. Let's say I had a a typical equity valuation kind of a model, but I am using that equity valuation model to probably value, or probably I have a Black-Scholes kind of a model for doing an option pricing, but I am using that particular Black-Scholes model for valuing very long dated equity options or very long dated forex options, wherein probably the required rate of return, risk-free rate of return could change drastically during the period, as well as the volatility can change during that longer period. Whereas during a short period, Black-Scholes model is more and more applicable. Or probably I'm using a Black-Scholes model which is more applicable for valuing European options, but I'm using them for some American option valuation. So the model is correct, but I am using it for wrong purpose. That is an inaccurate application kind of scenario. Or probably the model was developed 10 years back and I am using it now. It's an outdated kind of a model. Because today the way the business is done, the economics has changed quite drastically. So during the current time frame, that model may not be an applicable kind of a model. At that time it was correct, but today it is not. So which means I'm not applying the current model to assess my output, and at the same time, especially if I'm using a scenario like Monte Carlo simulation and all, we know that we need to generate large number of trials to typically use the Monte Carlo simulation to a very effective level, but I am generating only very few trials. So in a simple nutshell, if at all I am not using the model correctly, in the correct place, or using an outdated kind of a model, we associate it to incorrect model application as a source for the model risk. Then the third dimension I am looking at is the implementation aspect itself. The inputs that are typically being used to build the model. If I have used A, B, C, D as the inputs, now even the estimates to get that A, B, C, D, that itself could be an erroneous thing. Right, whatever the various, some estimates that I am using, let's say to get volatility or the risk-free rate of return or any of the scenarios, whatever the inputs that I am using to build the model, even that inputs I did not collect them properly, then my model formula will come out to be a wrong thing, which could very well lead to a model risk, because that is also a loss that is coming up, or a risk that is coming up because of the wrong model. Then there could be a calibration related stuff, wherein probably I did not consider the proper calculations, right? Whatever the let's say the input parameters and all I am using, or input time periods that I am considering, they are not appropriate. Probably I might have used all the data only specific to a boom period, but I did not consider the recession period data. So whenever we are getting into some kind of calculations related stuff, we are considering it as a calibration error. Then there could be a programming error because of algorithms and code, wrong programming done, programming errors, bugs in the algorithms. All these things get classified as programming errors. Even that is a source of model risk. And finally, data related. Especially when I am collecting the data from third parties, understanding the goodness or the fitment of the data for our analysis purpose. So on what basis they have collected this detail? What are these details? If I am talking about let's say the prices, is it the average price for the day, or is it the price at the end of the day? Is it the last traded price of that particular day? What do we mean by the closing day's price? Or when I say average price for the day, what is it? Is it low plus medium plus low plus high by 2, or what are is it like all the prices of that particular day divided by the total number? What do we mean by the average price? Especially when some third party has published that data, I need to be even more careful in terms of assessing the goodness of it. Otherwise, it goes under the mechanism called garbage in, garbage out. GIGO principle is what we typically call in the information technology world. Any garbage that is coming in, garbage going out, adding no value to our analysis. So these are the multiple dimensions from which we can typically look at the model risk. So understanding of a model risk is one of the key aspects as far as the operations risk management is concerned. Then the next aspect which we are looking at is how do I estimate this model risk? Here we actually look out from 4 different perspectives. How do I estimate the model risk? Now, for estimating this, let's say while developing my model, look at this scenario of developing a model. Let's use developing a kind of option pricing model. When I am doing this option pricing model, there could be n number of unknown parameters, right? When I am using a Black-Scholes, I mean I am not calling it as a Black-Scholes option pricing model. I am thinking of some XYZ model for option pricing. Now out of this, I would like to look out for on what factors is this XYZ model depending on 1, 2, 3, 4 factors. Now out of these factors are out of the various factors that I am considering, there could be a possibility that one of them could be an unknown, there could be multiple unknowns, 2 unknowns, there could be multiple unknowns. All these scenarios can come up. Now what we are saying is, in case there is only one unknown kind of a parameter, one way to estimate is, for this one unknown, you try to assume a distribution. So assume that this particular let's say volatility is an unknown, or probably sigma or var is an unknown parameter for that model, or volatility sigma is an unknown parameter. Then what I can see is, assume that this unknown parameter follows some kind of a distribution. So probably I may assume that the variance, or probably even a value at risk, it follows a kind of a chi-square distribution. I may assume some kind of a distribution that it will follow, and based on that you build the confidence interval. Now if I say that the variance follows a chi-square distribution, so if the variance is following a chi-square distribution, so what is the statistic for a chi-square distribution? N minus 1 s squared by chi-square. That is the statistic. So what you assume is, you assume that your the interval which we are trying to build is your variance will lie between this, probably at 95% confidence significance level, to 5% significance level. So this is the range for your variance. So you are assuming that the variance will follow a chi-square distribution. So here the important thing is, you assume that that unknown parameter will follow some statistical distribution, and based on the properties of that particular distribution, you can very well assign the interval for the same, and based on this you could compute the model risk that is present. Similarly, if someone is talking about var is what, or probably if the same thing I have to expand, take the square root n minus 1 by chi square into s is less than sigma, and this is at 0.95, and a root of n minus 1 by chi square into s, this at 0.05. Now when we talk about the var, it is minus sigma times the z alpha. So probably for all of them I do minus z alpha. I multiply across by minus z alpha. So this is what will be my, so this is nothing but my var, and from here I know the 95% confidence interval limit or something for my value at risk. So if at all one particular variable is not known, only one particular parameter is not known, the simple way is understand what is the distribution that is going to follow, and based on the characteristics of the distribution, build an interval around it and use it for your risk estimation purpose. Then the second thing, if at all there are two parameters, same way, you treat them as two different parameters. Understand what is the underlying distribution for each of the parameters. Right, for each of the parameters, let's say I don't know how many losses will occur during a period, and also what is the severity of each of the loss. So this is a scenario of two unknown parameters. So assume that the frequency of losses follows some kind of a distribution. Let's say I assume that frequency will follow a Poisson distribution, and severity of losses I may assume that it will follow a log normal. So for each distribution, for each parameter, try identifying the distribution associated with it and repeat the number of experiments. Try to compute the overall risk that is inherent in these experiments. Try finding out that the distribution of your output variable, and that is what is the building of your model risk. So if there are two parameters, that's the way it works. But if there are multiple unknown parameters, so apart from frequency, severity, I don't know, even x, y, z. Now what we are saying, build a kind of variance covariance matrix between all these things. So if there are means, pull them from normal distribution or a t distribution. If there are variances, pull them from a chi-square distribution, depending on what all are not known. So there are multiple risks for which means are not known, multiple variances are not known. So what you can very well do is you can pick all the means from normal or t kind of distributions, pick out, simulate the variances from a chi-square distribution, get the combined values and try to create a distribution for them, and try to also find out the intercorrelation that is existing between these variables. So that is how we go ahead in terms of estimating the model risk. And then one more dimension is, even if the distribution, till now we have been assuming different distributions for each of the parameters. Now what can happen is, if I don't know the distribution of that parameter itself, so I don't know whether the chi-square which I am using, or probably the frequency which I am using, I don't know whether it will follow a Poisson distribution or a binomial distribution. So where I am not clear about the distribution of the parameter, we talk about the mixing. where we talk about the mixing part, where we say, okay, I'll try Poisson distribution with some probability, and I will try binomial distribution with some probability. So the when I am trying to pick up the frequency, I will see. I mean, I'll use some kind of random number kind of a mechanism to decide whether I should draw from a Poisson distribution or a binomial distribution, and I'll draw it from here or here, a particular observation. Corresponding to that, I'll generate the severity, and I keep generating. Means probably there is a 60% chance that I will pull it from a Poisson distribution, and a 40% chance I may pull the frequency from a binomial distribution. But wherever I am pulling the frequency from, the severity will be pulled from log normal kind of a distribution itself. Then I integrate the values and generate a new distribution, which would be a distribution for my risk. So like that I can find out the VAR associated with the model risk in this particular case. So all these are the various mechanisms that can be used for the identification or the estimation of my model risk. Then now that we know that the model risk is present, what are the different ways to protect against the model risk? Because any model risk could result in some kind of losses. So there should be a mechanism to protect against the model risk, for which we say we should understand the limitations of the model. No model is perfect. So we should understand the limitations of the model, under what scenarios the model is appropriate, and where the model is not appropriate. Use the model only for those areas where the appropriateness exists. Analyze the sensitivity of the model to key assumptions. You keep changing some of the key aspects. Probably if I am pulling out an option pricing kind of a model, probably yes. If the interest rate, risk-free rate of return changes, if the volatility changes, what could be the impact on the final output? So try to find out the sensitivity of the model to the key assumption and see if something is completely drastically away from the reality. Some addressing has to happen to that particular model, and at least if there are some known solutions, it's always better to test the data, test the model with the data for which we already know the answers. Probably if I am using let's say if I want to build a model using the last 10 years data, sometimes what people do is they may build the model. Let's say I have 40 quarters to build the model, last 10 years 40 quarters. Now what may happen is, in fact I will build the model only with 30 or 32 data points, and the remaining 8 or 10 data points I would use them for the testing purpose. I will not use them to build the model, I will use them only for the testing purpose, which means there should be consistency in the output that is given even when I am substituting those new values for whom I already know the output value. By substituting them, my model output should be more and more closer to the real output. So there should be a level of consistency between the model outputs when I substitute the inputs which have gone into the model versus inputs which have not gone into the model. That is what we typically call as in sample versus out of sample. So that I can test this model with a completely new set of data if the consistency exists under these two scenarios. Then try to keep the model as much simple as possible, because as we have discussed, the more complex the model becomes, the more possibilities of not capturing the relationships between the various inputs, which could directly result in increasing the model error. So unless it is very much essential, there is no point in complicating the model. And it's also advised that backtesting as well as stress testing, you create some predefined or on a dynamic note kind of stress scenarios, and based on that you can very well test the model so that you can understand the limitation. Okay, it works only under normal situation, but under an extraordinary or extra normal kind of situation this model will fail. And you also try to understand that it's very difficult to capture all the risk. The more and more effort goes in terms of capturing all the possible risk. Otherwise, the model risk will always be higher compared to the estimate, because when you keep omitting a few factors that contribute to the success of the model, to the goodness of the model, and if you have omitted some of those parameters, it's a straightforward thing that the model risk will be higher than what is estimated. And the other important dimension that needs to be looked at is we may ignore a problem saying that it's a very small problem. But what could very well happen is, because of the volume of the transactions that it could result in, probably my overall error is going to be a very drastically high kind of a scenario. So we need to give, which means though it's a high frequency, low severity kind of errors, even these things have to be focused quite heavily. Then outliers, is the data handled properly? What is the mechanism that is being used to identify the outliers? How did we test the residuals? Is there any kind of dependency of the residuals on the independent variables? Right? Is there any kind of possibility of conditional heteroscedasticity present in the data? All these kind of things have to be thoroughly analyzed before we can get into the controlling of the model risk. So we have to keep upgrading our models quite thoroughly, quite frequently, so that they reflect the real world to a large extent. So from a senior management perspective, there is a very important role. So they have to really understand what model risk is, what are the different mechanisms in which the model risk can get introduced into the system. And so any model that is typically developed, they should get into the critical questioning of the inputs being used, the calculations that are being done. So in a way, they have to promote a culture of risk management within the organization. And just like any other performance evaluation they do, it is mandated that they even track the performance of the model, see how well it is aligned with the reality, any errors coming up, do an understanding of why the errors are creeping up, see if there is something else that could be modified to the model so that the errors are coming down. So they keep using the you revise the model at regular intervals and make sure that no one is misusing the model. The wrong usages of model generally don't occur. So all this thing is a responsibility of the senior management to take care of, to ensure that the model risk is much lesser. Then if we are trying to review a model, right, to ensure that the model risk is reduced, we have to do a review of the model, which is straightforward. Okay, you ensure that the completeness is there. Try to test out all possible inputs, see whether the outputs are coming out in a proper way or not. All the most common kind of basic assumptions are taken care into the building of the model. Are all possible regular scenarios are being working quite appropriately. So you ensure that the completeness is there in the model. and probably if required look at the documentation, the code that is generated, try to do a direct review of those things so that no calibration related errors or no programming related errors crop up as a part of the model, and try to see the appropriateness of the model. Make sure that you are not using a wrong model. So for the kind of data whatever we have, understand whether this particular model is appropriate from a conceptual or from a theoretical standpoint. Then test the model against a benchmark and even from a no arbitrage relationships. So using the model, the person should not be able to create an arbitrage profit when in reality such a kind of arbitrage is not existing. So it's better that you have to test the model by creating some such kind of no arbitrage kind of scenarios, and try to see whatever the output that it is generating in two different conditions is more or less the same. Regular auditing of the model and the principles and procedures or the algorithms that are being used to build the model, they all need to be reviewed and audited properly, and efficient record keeping of the audits, findings, observations, improvements, revision history, all these things is done quite comfortably and effectively. That is one thing that needs to be made sure for an effective implementation of the model. Then the other thing we are looking at is, in an organization, it is advisable to have a middle office kind of thing which is responsible for the risk management across the firm, enterprise risk management. So this is responsible for the overall risk measurement and the management at one point kind of a contact. And it is in some organizations it is even seen that the head of this IRO, he is directly reporting to the CEO, and in some cases he might be there on the board itself, especially to formulate some kind of risk related strategies and communicating the risk related performances or risk related strategies. For all these things, a person who is in charge of IRO, he may be a CRO himself, Chief Risk Officer. So that person may be reporting directly to the CEO, and even he may be on the board of directors also. And make sure that this particular unit, it is slightly isolated from the regular business lines, from the regular risk generating units. This unit should be independent of. So completely it should be away from it should not get into the pressures from traders or front office or any of them. And the position limits also, they should set the limits. To what extent you can use leverage, to what extent you can go short or long on a position, what is your VAR limit. All these things the company can the IRO can set to the various departments based on the overall risk taking behavior of the firm. And at the same time we should make sure that for the IRO and the team IRO, their compensation need not be tied up with the performance of the other units. It's a complete, so it should not be tied up with the performance of the other units. It should be completely on an independent basis. Otherwise there is a possibility that these two departments, the regular line front office and the traders kind of desk, they will collude with the IRO, and finally that may result in not meeting up the objective in any way, and the models that are getting developed might not be reflecting the reality at all. So that is what we would like to discuss as a part of the model risk. In case you have any further queries or clarifications regarding the same, you can get back to me by giving me a call on the number that I have provided below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.